Hello everybody, this is the MATLAB and Simulink Racing Lounge. And in today's episode, I'm going to tell you how to make your MATLAB experience more productive. Or to say it in easy words, I will show you some tricks and tweaks how to make your life in MATLAB a lot easier. So let's get started right away. Here is the beginning of a list of productivity tools that I will introduce you to. Well, what I'm going to do in that episode is to jump back and forth between these slides and MATLAB and to talk you through some productivity tips that will actually help you. So let's move on to MATLAB. Well, first question is, I'm sure you're dealing with sensor data that you have available in text format. Well, similar to that one here. We have a text sheet. We have, well, probably several columns. The columns are separated with semicolons. We have decimal separator, which is a comma. Well, this is quite common in Germany, not so much in the US or UK, but I will show you how you can deal easily with that. So what we are going to do is import the data in MATLAB, because all the data processing should be done in MATLAB. You can use the technical computing workflow, and I will show you how easy it is. Well, if you're in the Home tab, you're already at the right spot. We use the Import Data Wizard, which comes up as a GUI. That will help us to make some decisions and to import the data right away. So we have to specify some stuff. So the column delimiters are semicolons, just semicolons. And we always have a preview in the bottom of the GUI. This tells us, well, we will end up with 5 columns, which is about right. Under more options, we can specify the comma as decimal separator, which makes perfect sense. We want to import all data, and in that case I guess table format is the right variable type to get this information in MATLAB. Well, what we can do, click import, and we have this variable in the workspace right away. Or what we can also do, we can generate a script from that. This is what I'm doing right now. I will save the script. So now I have saved the script and I will let it run. Well, it takes 2 or 3 seconds, and then we have the variable called labs, same name as the text file in the workspace. Let's have a look at that. Well, looks pretty good. So we have numerical information here. We have 5 columns. What is not perfect, due to the text in the first 2 lines, we have this as not a number, N-A-N. Why not removing that quickly? And this is very easy when we are dealing with scripts. Scripts allow you to redo that stuff and to reuse the script. Well, what I will simply do is I will say, okay, the new variable called labs is the old variable labs, but starting from the 3rd line to the end. We could also write end. And we take the 5 columns. Good. So I will save the script. I will clear everything, clear the workspace, you see it here on the right, and let the script run again. Good. Now we have the labs variable again, but with 2 lines less. And if we have a look at that, well, makes perfect sense. We have the right format, and now we can go on to work in MATLAB with that. Okay, what have I shown you? Well, import tool is a powerful feature to get your data to MATLAB quickly. So a second feature that I'd like to introduce you to is the command history. So if you use the up key, so the up cursor, the up arrow, then you will have access to a long list of commands that you have done before. So this is especially helpful if you are sure you have used that command the day before and you want to get back to that. For example, in that case, it clears the command window, just as an example, or you want to compare some files. Well, you could select that. If you either hit enter, then these commands will be executed, or by right-clicking, you can even generate a script from that. So the second information that I would like to remember you is nothing is lost in MATLAB. So even if you haven't created a script from your commands, you will have access to your commands. Well, pretty interesting. So now coming to a topic that I like very much, it's tab completion, because it makes life in MATLAB a lot easier. For example, assume that we have a matrix. I would quickly create one with random numbers, and it should be a 5 by 5 matrix. Okay, what we see here is a 5 by 5 matrix with random numbers. And now what I want to do is I want to create the inverse matrix. And I can't remember the inverse command. Well, what I usually do is, I guess it's called inverse or inv something. I will hit the tab completion. So I will hit the tab button, and then I'm confronted with a list of functions. And in that case, MATLAB makes life really easy. I'm using the inv command. Just hit enter, and then I'm pretty sure that it's the right command. If I then open the brackets, it will instantly show me some, or it will instantly offer me some more help on that function. So if I'm not sure how to input the matrix here, well, I will click on more help. Then a short help, so not yet the documentation, but a short help will pop up and give me some basic information about that function. For example, it says env returns the inverse of the square matrix. A warning message is printed if x is badly scaled. Well, this is pretty good. So what we can do is we input matrix. Well, this is a nice feature in case you know the function, or you know the functionality, and the tab completion actually helps you to make life a lot easier. Okay, now in case you're really looking for a functionality you can't find, well, I suggest to use the doc command. Well, doc is access to our documentation. It's simply doc, then space, and then you can type whatever you want. Either you know a function and you want more information on that, or you can type a buzzword there, a keyword. In that case, let's use the same functionality. And now we have access to the documentation. We have the inverse function with a lot of explanations. Usually the documentation comes with examples. So that's what you see here, how you can use it. And what is extremely interesting, always at the last lines of an article in the documentation, is the see also section. See also offers you similar functions that might be helpful. So this is extremely helpful when you're working with a function that does about the right stuff, but not exactly the right stuff. So I think it's worth having a look at these functions to help you out in a tricky situation. Well, pretty cool, using the doc command. Okay, now what I see from you, you're plotting data really often, and I will show you how easy it is to create a plot. Let's have a look at the labs matrix again, or the labs table. Let's say we want to plot the latitude, column 3, over time. Well, firstly we create vectors based on these based on this table. Well, first is time. Then I know I have to convert data within a table to a numeric array. I'm here also using the tab completion. So it's usually table 2 something, but I'm not really sure what it is. Is it an array, cell, dataset, or struct? Well, it's probably an array. Okay, and then I'm saying, okay, I take the labs, but just the first column. Now we have a array with the time values. Now I'm using again the command history, just going up, using the same command, but in that case I say it's latitude and specify the third column. So I don't have to type it, just up cursor, and then we will create that variable, latitude. Okay, so I just have to highlight both. I can use the control command to highlight both of them. And then if I go to the plots section, so to the plots tab, it offers me plots that are available for that kind of variable. Well, let's do it right away. So no typing, no clicking. Well, in that case, I've seen that I've switched between X and Y axis. This is not a big deal. Also, the GUI offers me to change that. And what I now have is the plot of the latitude over time. Well, pretty straightforward. So let's put a check mark here. Plotting is really easy. In case you have the variable available, just go to the plot section and you will be offered a lot of help. Now, for example, in case you want to deal with data, you want to do some curve fitting, I will introduce you to the curve fitting toolbox. You will find it in the apps section. In that section, you will find a lot of shipped, so pre-installed apps that will make life a lot easier. Today, I'm just going to focus on the curve fitting app, but as you see when you scroll down, you will find a lot of stuff here. So first of all, let's create some data that we want to do the curve fitting on. Well, I will create another time vector. In that case, I'm creating it from scratch. Well, I just want to have a vector which has 10 items or 10 entries, which go from 1 in steps of 1 to 10. Time vector. Let's have a look here. 1, 2, 3, 4, 5, 6. And then I want to have a data vector. Data vector. And I specify it with random numbers. Well, I know that it's not the smartest thing to curve fit in random numbers, but in that case, just want to show you the functionality. Okay, what I will do here is I will also create a vector with 10 entries, ranging with values ranging between 20 and 30. Well, what would you do in case you want to get more information about the Randy command? Well, doc Randy, and it will show all information about the Randy functionality here. So what I've done, I've created the data vector. We will see it on top. Well, it's numbers between 20 and 30. And what I'm going to do now is open the curve fitting app. Well, also a nice GUI that makes life easier and that will help us to deal with that. So what is the X data? It's a time vector that we've specified. The Y data is the data vector. And by just selecting that, MATLAB starts a certain routine that already pre-processes the information. And we already have some results, preliminary results. The results here are based on a polynomial fit of first degree. That means it's nothing but a linear fit. Well, which is about a smart solution here. We could also go up to level to a polynomial or quadratic interpolation. Well, I know this is not a realistic data set here, but what you will see is it will plot the data. It will also plot the fitted curve, and it will provide you with all fitting coefficients. Well, what you can see here, it's pretty easy if you have certain data available to curve fit these data. Well, we don't want to save anything on that here. So I've told you about the apps. So there are plenty of apps shipped, and I've told you about the plots tab. Well, makes life really easy. Now I'm going to show you some tricks and tweaks how to deal with scripts or M files in a very efficient way. What you see here is a script that can be folded up and folded down. Well, how does that folding work? Well, it's pretty easy. Some of you might know if you put a % sign in front of a command, it will be commented out. If you put 2 of the percentage signs, it will be created a section from. Basically in that document I just have 2 sections, and well, these sections can be folded and unfolded. And this makes long scripts particularly nicer to read. Well, just to show you that it actually works, I will say here, third section. And if I write something like a equals 10, it can be folded up and down. One very nice thing that in order to get a very quick overview about certain files is if you pre-select some data in your current folder, it will always show you how many sections this has. And if you remember a certain section, well, you can directly go to that. Well, going back to our file here, we have 3 sections, and well, they are highlighted here. I could go to that, I can click on it, and will end up right away in that section. So this is from my point of view, this is a very nice feature in order to structure your code. Well, very cool. So now let's have a look at that code. You will see that I've implemented a for loop. And then I might think of sharing that code with a colleague. But well, I've cheated a bit in programming. I've called some variables temp, which I should never do, but well, I was in a hurry, I did that. I would like to rename that, and this is very easy. I would like to rename not only this instance, I would like to rename all the instances in my script. Well, what I do is to rename the variable, good name, and if I now press Shift and Enter at the same time, it will rename all instances. So I go back, the variables have been called temp, and now I've renamed one instance, and not just pressed Enter, but pressed Shift Enter, it will rename all the instances of that variable. So we call that automatical variable name change. Well, and here are some more productivity tips. Let's start with the debugging. Well, let's assume that you're working with a script, and I will show you how you can efficiently debug your code. Well, going back to the same script, here, I will just let it run. Well, before I will let it run, I will show you the code analyzer that is always automatically screening your scripts. Well, what does it say here? Just hover over that line, over the orange line. It says line 7, the variable a appears to change in size on every loop. Well, let's check that with a for loop, and we are specifying a certain variable a. Well, and right, it's growing with every iteration. This is not very memory friendly, so well, the workaround in that, it's also specified here, consider pre-allocating for speed. Well, pre-allocating a certain variable is not a big deal. We can do it like this. It takes 1 or 2 seconds, and then the script appears to be green. Green means no warnings found. Well, good to know. I will let the script run, and I'm confronted with an error message. Well, what does it say? Undefined function stupid for input arguments of type double. Well, I've just typed stupid. It's not a proper MATLAB function. I've not created that stupid function. Then, well, it throws an error message. Well, what I can do is I can set a breakpoint here. It's just clicking on that line, right-clicking on that line, and I will let it run again. So now we are in the debugging mode. We can see that because we are in the quit. Well, we can quit the debugging. And what we can see is up to that one, we don't have any error. If we continue, the error message is thrown. Well, the breakpoint is a particularly good thing if you want to make sure that certain parts of your script are running nicely. Well, put certain breakpoints and step through the script. Well, we can do it again. I will run, and then I could continue. And I will end up at each breakpoint and check what the variables do, whether everything is correct. And this allows me really easily to find errors. Well, if you right-click on it, you can clear a breakpoint. Well, if you're done with something, well, you can clear it with a right-click and can continue working on. What you also can do is, if you're in a section, you can run your code section-wise. Well, this is a bit of philosophy question. Either you define sections and make sure that they run properly, or you work with breakpoints. So it's not just the run button here. You can run sections, you can run until the breakpoint. Well, this is always happening. Or what you also can do is run in time. Well, if you want to make sure that your code is performant, well, you go to run in time and you're confronted with a profiler, and the profiler tells you how much time did MATLAB spend on certain functions. Okay, going back to that. Well, debugging is really easy. You can work with breakpoints, you can run your code section-wise, and in that case, I will fix that. Stupid is not a function. I will create two random matrices, two random vectors with well, one is a column vector, one is a line vector, and I will let it run, and now it creates a 10 by 10 matrix called C. Okay, so far so good. Let's check what we have done. Well, you have seen the MATLAB code analyzer. that runs automatically, and you have seen how to set breakpoints. Well, pretty nice feature in order to go through your code stepwise. Now I'd like to show you something about reports. So first of all, I will uncomment a certain fraction here. It's a section called fix me. Well, fix me, I guess you will type fix me in case you are working on something, you had to stop, but you want to leave a check mark that you should continue working there. Well, this is a very easy thing. If you click on that arrow here, you will find a to-do or fix me report. Well, especially for long sections of the code, it will find to-do, it will find fix me, or it will find whatever. So if you like to specify your construction sites with whatever, well, it will also find that. And what it tells me here is that in the source.m we have a fix me command. Okay. So, but this report is not the only report you can draw from that. You can have a help report, you can have a content report. You also can systematically perform the code analyzation. Well, in that case, we know that this script that we are working on right now has no error messages. But if you want to let that script run frequently and check what has changed, what appears, you should use that. Well, a very important feature are reports, because they really help you to analyze your code and to get quick solutions on that. Very good, very good. So this is just an example, the to-do and fix me report, but reports in general are very helpful. So now I'd like to talk you a bit through the shortcuts. Well, perhaps you have seen, I've used that one before. I just called it cleanup. It's a shortcut. I could create plenty of them. If I right click on this and say edit shortcut, well, it's very easy. I can specify a certain name. I can write down some commands here, and I can write whatever a suitable MATLAB function is. I could add certain folders or files to a path. I could run a startup script. In that case, I simply clear all variables, I close all figures, and I clear the command window. And if I just click that, my workspace will be cleared, my command window will be cleared, and in case I have open figures, they will be closed. The cleanup is like a shortcut. Now I'm going to show you how you can further improve this shortcut functionality by working with startup scripts. For example, I'm going to a demo. In that case, I let the startup script run. Well, and then it creates me a HTML file. Well, with that I can do plenty of stuff. So this can be interesting if you want to show your colleagues with something, or if you have repeated steps and you want to redo them again. So it's not only possible to clean up some stuff with shortcuts, you can even execute scripts. In that case, we have the publishing function. Well, we have had a Racing Lounge episode about publishing. We have used the publishing functionality to create a script with HTML links, and we can work through that in order to let the model run, to specify some stuff, to simulate it, to deploy it. So we can even go far beyond shortcuts by creating startup scripts. Let me know in case you are interested in that. I can share some files and share some code on the MATLAB file exchange. Okay, I've talked about shortcuts and startup scripts. Now I will talk a bit about the profiler and the TikTok command. So basically the headline of that is timing. So let's open the script again that we've worked with. That's that one here. And if I want to evaluate how long it takes MATLAB to evaluate the inverse of a matrix, well, I can work with the TikTok commands. Tick means nothing but starting a certain stop clock, and tock says, give me the time that the clock currently has. Well, I will put it right after that, and then I will let the script run. And what you can see here is, okay, it takes some milliseconds to calculate the inverse of a matrix, and as the for loop is executed 10 times, well, we will get out 10 results for that. Well, this is the quick and dirty approach how to get some timing, but you will also find that using the profile I've already introduced you, you will find all the time that MATLAB has spent to execute a certain script. Well, and then it makes it quite easy to accelerate your scripts, because you will always find where MATLAB spends most of the time on, and these are the sections of the code you should work on. And you could think about parallelization or use simply more efficient programming techniques. Well, first of all, always make sure that there are no warnings. Especially this memory allocation can save a lot of time. Okay, well, tick-tock timing should be an easy thing. So sometimes that frequently appears to me is that I want to compare certain scripts or certain text files, and I'm working in MATLAB and I want to do it right away. Well, in that case, I'm using a functionality or a function that is called visdiff. I just have to specify some variable names. In that case, it's two text files. Well, it's the labs file that we've worked with, and an edited version of the file. Well, before I execute that, I will open that also. What we see here is, don't want to save that. What I see here is the old labs file, and this is the edited labs file. Well, I could scroll, and I won't find a difference. The lot smarter way is to do that, and it takes 1, 2, 3 seconds. The text files are compared, and what I will find is a difference here, and it also specifies where the difference is. It's in line 1383. This is the original file. On the right, we have a certain number here, 47 point something, and here I've just written minor edit. Well, try to do that in that file. Well, just to show you that MATLAB is correctly working, I go to the respective line, and what we'll find here is minor edit. Well, hope this is a very interesting feature for you. That's one that I definitely use quite frequently, and I definitely appreciate it. So finally, and last but not least, I will introduce you to some control plus some other key commands. Therefore, I'm going to the next slide. In order you want to stop execution of a certain script or model, well, just go Control C. So it's not copy, as for example in the Windows environment. It's in that case in MATLAB the execution is stopped. Control D. Well, this is a very interesting function. For example, let's go back to the script again. If we go inverse, just click the cursor there and say Control D, the function will open. Well, in that case, it's not very interesting because it's a MATLAB built-in function, so MATLAB won't tell me how this function is compiled here. But in case you are working with your own functions, well, that's definitely a very powerful tool. In case you want to find something in the script, Control F. In case you want to go somewhere in the script, well, you can try it here. You can specify a certain line and just go there. This is also a nice feature, Control I. For example, if you have for loops and you have for loops and for loops and for loops, well, what you can do is you mark everything, press Control I, and it's all aligned perfectly. Well, this makes structuring your code a lot easier. Well, these are pretty straightforward. Open, save, and print. Well, and in case you didn't know it before, Control R comments some things, like here. And for example, Control T, well, it comments, and Control T comments out. Comments out. Well, pretty easy. And this brings me to the end of the episode. I hope you enjoyed watching, and I hope you learned something. In case you want to get a more in-depth introduction to productivity tools in MATLAB, I would like to introduce you to a webinar that has been published recently. You will find it on the MathWorks video page. I will provide you with a link in the video description, so no worries, you don't have to type that. You will also find some other productivity tools within the MATLAB file exchange, within the MATLAB news, but this is the most recent one and I really liked it. So this brings me definitely to the end of today's episode. The key takeaways are basically for every ailment under the sun, there's a remedy or there's none. Basically, the key message here is MATLAB experience shows that there's usually a remedy. I hope that each of you learned something in order to improve your work with MATLAB and in order to make your MATLAB experience more productive and to make your life with MATLAB more easy. So, last but not least, I'd like to introduce you again to our Formula Student resources. In case you want to watch other episodes of the Racing Lounge, suggest to go to the mathworks.com/Racing Lounge. Well, in case you are part of Formula Student Germany or Formula Student UK, just go to our respective Formula Student web pages. We are very keen on receiving your feedback, so please take the opportunity to mail us your questions, your feedback. Let us know whether you want additional episodes of the Racing Lounge covering a topic that is relevant for you. We have a Formula Student software offer, so in case you are taking part at Formula Student Germany, Formula Student US or Formula Student UK, you have free access to our software, so take that effort, go ahead. It's a pretty straightforward and lean process. And in case you use our support, our software support, we would appreciate if you put our logo on your car and your reports. So thanks for watching, thanks a lot, hope to see you next time, bye bye.